So hello guys. So in this session we are gonna study about conditional loops. So until now we have compared whatever the concept that we studied with a newborn baby, right? Let's go with the same flow itself. Imagine there is a baby. First the baby repeats whatever that we say. Next the baby understands whatever that we say, remembers whatever that we say, and the baby then makes some decisions based on whatever that we say. What is the next thing? The baby just grows up. After a while they join school, and regular routine is happening in the child's life, right? Morning they wake up, they go to school, study or sleep or play, or come back to home again, eat, sleep. So it is more like sleep, eat, work, sleep, repeat. So those kind of things. So this repetition of doing certain things again and again and again at until certain point. So what is the certain point in a child's life? The certain point is like until I complete my 12th, or else after joining college until I complete that 4 year, or else until I complete my post degree. So there is always a loop that is running in our life that has some certain end condition. So in the same way, we can implement the same concept inside our code in the name of conditional loops. So these conditional loops starts with while loop. So you can see like there is a syntax given over here. There is generally three types of loop that we handle with loop. While loop, do while loop, and for loop. So here we are saying while loop. So you can see like initially we are given like int count is equal to 1. So that is our initialization. So when it comes to what to say, when it comes to loop, you have to understand few namings, nomenclatures, which goes like initialization, condition, updation. So for loop, these three are the main factors. So you see, int count equal to 1, that is our initialization, that is the starting value. So when we come to the next statement, while count less than equal to 5, that is the condition. Unlike when we saw this if condition, right? There was a if, there was a condition, and below that whatever that is written inside the curly brace will be executed for how many times? Exactly one time. But over here we have the while loop, we have the condition, and then when we come inside we have some print statement, that is the executable statements. And over here you can see like count plus plus, right? That is our updation. So initialization, condition, updation, all these three. Okay, so to understand a loop you must understand how many times these are getting executed. So shall we check? So initially the initialization is executed for only once. Fine. After that, when we come inside, 1, that is count value, 1 is less than equal to 5. So it is true. I come inside. As of now, the condition is executed for once. When I come inside again, I'm actually printing the count value, and then I'm incrementing the count to 2. So updation executed for one time. So when I go for the next iteration, you can see like again my count is becoming 2. So after reaching this end curly brace, what I do is I don't go for the next statements. Rather, since the condition is not becoming false, I again start with the while loop. I'll check the condition, come and print the statement, update. Again, I'll check the condition, run the print statement, and update. So this process is done unless and until my condition fails. So since this is the second time I'm doing this part, so I'm gonna just write my condition was executed one more time and my updation was executed one more time. So another time, third time, okay, fourth time, fifth time. So I'll just erase it. Fifth time. So after executing for these certain number of times, when my count reaches 6, the condition fails. Exactly in this position, if you see carefully, my condition was executed. So my condition was executed for the 6th time, where it shows like the condition fails and it does not enter the while loop, because of which the updation will not be executed. So this is end of the while loop, and you can see like initialization executed only once. Condition executed for what to say 6 times, which in other terms we can say like n plus 1 times. And as of updation, it is executed exactly for n times. So I hope you understand what is this initialization, condition, and updation, and this is how it works. So when it comes to while loop, where and all we'll be using this part. So before going to do while or for loop and all, I want you to understand what is while loop, how are their inner factors working, and what and all for while loop is actually used. Technically, all three condition loops can be used for any situation that occur. But primarily we practiced, and it is more like a procedure that is followed. We use them for number crunching. So what is number crunching? Number crunching. To understand number crunching, just move to the whiteboard. I'll erase the unnecessary parts. Okay. So imagine I've given you a int memory with a value as 12,345. I want you to take this number and I want you to print it as 1, 2, 3, 4, 5. You can either put commas or you can just put some space in between. But I want them to be accessed digit by digit and printed. Or else, let us not take it to this part in the beginning itself. I'll give you an easy one. 5, 4, 3, 2, 1. Printing them one by one from the last digit. You might think like, sir, the previous one itself was easy. How can we go in reverse? Don't worry, I'll help you out. You see, to print a value, let's say like I'm creating a memory block called as val, and I'm saying val is equal to a modulus 10. I want you to perform this operation and tell me what is the answer. So if you divide 12,345 by 10, the remainder is 5. So technically, the val will be currently having a value called 5. Fine. So technically, val is having 5 now. And what is my next operation means? I will say like a is equal to a by 10. So what is 12,345 divided by 10? It will be like 12,345 point, sorry, 12,340, sorry, not 12,340, 1,234.5. But since it is an integer, a is an integer, it cannot take the 0.5. So it will just take 1, 2, 3, 4. So the next time when you try to access this val with the current a value as 1, 2, 3, 4 and modulus 10, 1,230 will be divided and the remaining 4 will be in the val. Okay. The next moment when you again divide a is equal to a by 10, it will become 1, 2, 3. And again, if you do the val is equal to a modulus 10 means 123 modulus 10 is 3. And here goes like that. 3 operations are done and 5 operations are done. And at the end, let's say like I'm having a value called 1. What is 1 modulus 10? 1 modulus 10 is obviously 1. I'll keep it in that way. But what is a is equal to a by 10? 1 by 10 is actually 0.1, which if you see it as an integer format, nothing but 0. So a becomes 0. So based on whatever that I said now, I'll ask you, what was the updation over here, what was the initialization over here, and what was the condition over here? So the initialization is the number 1, 2, 3, 4, 5 that you had. Okay, this is said to be your initialization. What about the updation? So somehow this 12,345 was shifted to become a 0. Which operation performed this transition so that 12,345 becomes 0? This one. So he is said to be our he is said to be our updation. So technically I haven't written any condition over here. So what is the stop condition? When we are stopping to execute exactly these two statements, are stopped been executing at some point. What point do you think? The point when my a value becomes 0. So the condition is unless and until my a is not equal to 0, I can be performing these two statements, val is equal to a modulus 10 and val equal, a equal to a by 10. But when my a becomes equal to 0, I stop this operation. So you can either pause this video and have a quick glance on whatever that I said. If you want, just rewind it for a bit and try to understand what's actually going on here. So once you are done with it, assuming that, I'll just go ahead and code this part. This is one of the number crunching that you're going to learn. So let me go to the coding area and I'm going to keep, let's say like I'll keep this value to be n, okay, or else a, because we discussed with a, right, a. So what was my initialization? Whatever the user input that is giving, that is the initialization. While a not equal to 0, that was my condition, inside which I'm going to write a statement like val equal to a modulus 10. So I'll get that 5, 4, 3, 2, 1 and dot. And I'm going to write like system.out.print one second. System.out.print. If I give ln means, that is like, print means it just prints. If I give print ln means after this print statement, it will automatically give a new line. Print val. Fine. And after this, I will say like a equal to a by 10. You can see this is my updation. This is my condition. And this is my initialization. But so since I wanted you to like understand this concept wholeheartedly, I voluntarily kept a mistake over here. If you have found it, well and good. So just pause this video and try to find what mistake is happening over here. Okay, assuming that you would have found it, I'm just going to move further. So if I run this, you can get like I'm actually facing some error. The error is I didn't initialize this val. So since I'm just going to use this val inside this position only, I can directly write it as val. Fine. Let me run this now. And still that says like an error. Okay. Let me find what is the problem with it. Seems like no problem. So I've given the input as 1, 2, 3, 4, 5. Ta-da! I'm getting the outputs. So 5, 4, 3, 2, 1. That is how we access those digits. Okay. So when I give a number, you are able to crunch those numbers and access those digits one by one. To make it more fun, what I'm going to do is, instead of printing the numbers directly, I'm going to print square of those numbers. So let me run this and give some values. And you can, the next thing you can find is every single digit is squared and given to you. So shall we make some more fun of it? Instead of just squaring and giving it, what we'll do means, let us square it, sum it, and then print it. So what I'm going to do is, I'm going to use a variable outside this while loop into sum, which initially I'm going to keep it as 0. Okay. Instead of this print statement, what I'm going to do is, I'm going to say like sum equal to sum plus equal to, sorry, sum equal to sum plus, okay,
Sir, I need the charge.
val into val. Fine. Okay. Val into val. So what happens over here is, I'm actually having a variable called sum, which is actually 0, and I'm creating square of each digit and I'm adding to this sum. So when I come out of this while loop, you can see like I'm writing a print statement saying to print sum. Let's see what happens. Let me give an input like, we are getting the summation to be 55, which I honestly don't know. What is the summation of, let me check. Summation of 25. Okay. Plus 16 plus 9 plus 4 plus 1, 55. Yes, of course, the squares add up to 55. So this is how you play with while loop. And one more thing, it is a theory part. While loop is actually said to be a entry check loop. So you might think like, sir, what is entry check loop? Okay, once again. You might think like, what is entry check loop? So you can see like over here, the condition is actually checked in the entry. If the condition passes only, I'm letting you to go inside this while loop. And based on this circumstance only, we are calling it as entry check loop. If the condition is failing in the entry, it will not be allowed inside. Okay, I hope you got that. And let's jump back to the number crunching. So generally when we are doing number crunching, let me show it to you. Just give me a minute. Yeah. So when you are dealing with number crunching, you can say like there is 3 types of number crunching: counting digits, accessing digits, and reversing numbers. Okay, so what about these actual counting digits, axing digits, and reversing numbers means? You can see like axing digits is the exact one that we did just now. So we technically accessed each digit of a given number. So that is one part of number crunching that we did. So what about the rest? Counting digits, to count how many digits are actually available inside a given number. So if I say like 12,345, we are technically handling 5 digits inside that number. So that count 5 is actually needed. We'll see how to do that part. And what about the next thing? Reversing a number. So reversing a number, you can see like these two are said to be counting digits and axing digits, where we play with digits. But when it comes to over here, we are reversing a number. That means if I say like I'm going to write reverse of 1, 2, 3, 4, 5, it is 5, 4, 3, 2, 1. The only difference is I'm just reading it as 54321, but it should have its arithmetic value when I say it as a number. 54,321. So the 5 should be in 10,000's place, 4 should be in thousands place, 3 should be in hundreds place, and so on as it goes. So shall we move to the next two parts, counting digits and reversing number? So once we are done with that, you will have some better idea of how to work with number crunching. I would recommend you to practice some questions, which I will mention at the end of this session. Okay. So let's move to the coding part. And here the same code is going to be used. Only difference is instead of sum, I'm going to use something called as count. Okay. Yeah, count is correct. And over here, instead of writing these two statements, I'm going to just keep this part. You see, it's going to divide my a value again and again and again until it becomes 0. So let us take in this scenario. My current a value is set to be, as of in the output side, 1, 2, 3, 4, 5. I divide it once, it becomes this. Divided twice, this. Thrice, 4 times, and 5 times. Exactly after dividing 5 times, my a value becomes 0. And now, as of here, our idea is to study how counting digits works. So to count digits, you have to not to do like much of work. Just count plus plus over here, denoting it counts how many times the loop is running. So once you are done with it, come outside of the loop and print count. Right? Let me run this and let me give an output. This time I'll just give 3 numbers. The count is 3. Rerun it and I'm going to give some numbers. 6, you can see. So that's how we count the numbers. But when it comes to reversing a number, sorry, counting digits was easy, but when it comes to reversing a number, as I said, if I give you a number called 12,345, it should be reversed as 54,321, having its arithmetic value. So how are we planning in doing that? Let me explain it to you. So I'll just erase that existing parts. So you see, let me have a variable called as reverse. Which is initially set to be 0. Yeah, 0 would do. Okay. And let me have a variable called a, which has a value of 1, 2, 3, 4, 5. Now what I'm going to do over here is I'm going to tell you what operations I'm going to perform inside a loop. First thing, collect the last digit. So I'm going to collect the last digit in val. Val is equal to a modulus 10. So technically I'll collect the last digit in val, and after collecting it I'm going to use one small formula on reverse. Reverse is equal to reverse plus val into 10. Should I give 10? No, I've written the formula in the wrong way. Reverse into 10 plus val. Yeah, this would work. Okay, I'll tell you, just wait, I'll tell you. Okay, and updation part, a is equal to a by 10. So while studying accessing digits, you would have seen this statement and this statement. So you access the digits in val and you degrade the last right side digits one by one using the a is equal to a by 10. So what is this part? So let us see what it does actually. Okay, so you see, initially reverse is set to be 0. So what is 0 into 10? So 0 into 10 is 0, and the first val that access is 5. Okay, so we initially access 5. So 0 into 10, reverse into 10 is 0 into 10 is 0, plus 5 is nothing but it makes it to be 5. Fine. Now currently I'm having reverse value to be 5. In the next iteration, I'll be having control of 4. We'll be accessing 4. So when I come with a val value as 4, you see reverse into 10. What is the current reverse now? 5. 5 into 10 is 50, plus what is the current val? 4. What is 50 plus 4? It becomes 54. So currently my reverse value is not having 54,000, but at least it has a value called 54. So you will gradually understand that now 5 was in the 5th position, then it became 50th, that means 10th position. Later it will become 500, then 5,000, and then 50,000. So gradually it moves its position in arithmetic value. Let's see how it goes. In the next iteration, I'll be having val to be 3. So what is reverse? 54. 54 into 10, 540 plus 3. As you can see, as I said, my 5 has moved to its 100th position and the value is 543. Again, I will multiply reverse into 10, that is 5,430 plus 2 is 5,432. Then again, this will be multiplied by 10 and added to 1, which gives us 54,321. So I pretty much made it very clear to you guys. So if you're having any doubt, just rewind it and repeat it one more time. I hope you will get the idea. So if you haven't got it, means you can see like these are the 3 statements that should enter our while loop, and this reverse variable should be kept outside with the initial value as 0. So let's try make it in return state. Okay, let's go to the program, and in the same while loop, instead of count, so you can see like instead of count, I'm going to write it as reverse. Over in the print statement outside also, I'm going to write it as reverse. And instead of counting over here, as I said, I'm going to use int val equal to a modulus 10, and reverse formula, reverse is equal to reverse into 10 plus val. So shall we check it? So let me give some number over here. Okay, I'm getting in reverse, but what is the proof that I got 54,321? rather than just 54321 printed individually. I needed an arithmetic value, right? So to prove that, number one, there is only one print statement here, and the only way to print 5 digits in a one print statement, that is to be a single number. Even if you have doubt, I'll just give a simple thing over here. I'll subtract a 20 to this. So actual reversed value minus 20 will show you enough proof that we are actually converting it into a arithmetic value. Yeah, here go, bingo. So if you want to copy this or take a snap, make it quickly, you can pause the video and copy it, write it down, whatever you want. Practice these three things, because when it comes to loop, you must understand how these three things works: counting digits, reversing a number, and axing digits. And in case you haven't noted, just if you want, you can rewind the video and also see. While printing the count of digits or printing the reverse, we kept the print statement outside the while loop. But for axing digits, we kept the print statement inside the while loop, because we access digit only on certain number of iterations. The fifth digit is accessed in the fifth iteration. The first digit is accessed in the first iteration. It goes in that way. Okay. But when it printing, like counting the digits or reversing a number, it is just we collectively get an answer. We count the total number of digits and then print it, or we make a reverse of the original number and then we print it. So this is how this number crunching works, and we have too much of problems to be studied in number crunching. So what I'm gonna do is, I'm gonna just end this video with a small exercise for you guys. Okay, the exercise is like, I'm gonna give you 1 2 3 4 5, and I want you to print instead of printing 5 4 3 2 1, I want you to access them in the same order: 1 2 3 4 and 5. I want you to access them in the same order and print it one below the other. So I told you how to access the digits in reverse order. Figure out a way to access in the normal order. That is number one. Okay. What does number two means? 1 2 3 4 5 6 7. Okay, that is enough. I want you to access them, and you have to make a code in such a way that, just I'll show it to you better. 7 2 5. Okay, what's the problem here? 5 4 3 6 and 1. So yes, I hope you can understand what is actually happening over here. So if you see over here, exactly in this even positions, the numbers are same only. Second digit is 2, fourth digit is 4, sixth digit is 6. But as of odd numbers available over there, they are exactly reversed. The last odd number is coming first. The second last odd number is coming as second odd number. The third last odd number is coming as third odd number. So figure out to do these two exercise. Have a practice of number crunching. But keep it in mind, these will be like entry level of testing your programming skills when it comes to interview. The arrays and strings are actually the moderate level of questions that you might get. But as of now, until the content you have studied as of now, I would recommend you to practice these two questions to have a better idea of how loop works. So the do while loop and the for loop we'll see in the next video.